Nope, that's not gonna work. This is a series of video where I do a Leetcode easy problem in under 15 minutes. If I can't solve it in time, then I'm probably gonna give up and look for the solution and trying to figure out the solution. So I'm gonna keep shuffling through until I get an easy one here. Hopefully I get an easy one soon. This process doesn't really take long, but today is taking. Okay, there we go. So I always find it helpful to look at the solution and explanation before I look at the description. So what I'm going to do is that first. So input row 1, column 2, R centered 0, C centered 0. So that's the matrix. And then output. Explanation, the distance from 0, 0 to other cells are 0 and 1. Okay. Input row 2, column 2, R centered 0, center is 1, 0, 1, 0, 0, 1, 1, 1, 0. The distance from 0 to comma 1 to other cells are 0, 1, 0, 1, or 0, 1, 1, 2. Oh, wait a minute, hang on a minute. Row 2, column 2, center 0, C center 1. The correct answer 0, 1 would also be accepted as correct. What? I don't get this. You were given four integer row cost R center and C center. There is a row X call matrix. You are on the cell with the coordinates R center, C center. Return the coordinate of all the cells in the matrix sorted by their distance from R center to C center. To C center. From the smallest distance to the largest distance, you may return any number, any answer in any order. The distance between R1 and C1 and R2 and C2 is R1 minus R2 plus C1 minus C2. This is the most confusing question I ever seen in my life. The distance from 1 to 2 to other cells are 0, 1, 2. Excuse me. Okay, so that's 2. 2 times 2, 2 times 3 is going to be 6. So 1, 2, 3, 4, 5, 6, that's 6. 2, 2, that's a 4 by 4 matrix, so that's 4. Because R center and C center, what is R center? The distance from R center, from the smallest distance to the largest distance. The distance between two cells, R1, C1, and C1 to 2 is R1 minus R2 plus C1 minus C. Is that exactly what we need to do? R1 minus R2, so that's R1 minus R2, 1 minus 0 is 0. I don't get this. Okay. Center 1 minus center 2. I don't understand this question. The distance from between row 1, column 2. So we have one row and two column. That means we have this matrix. 0, 0. Right? The center is 0 and the R center. What is R center? There are X comma row matrix. You are given a cell with the coordinates R center and C center. You are given a cell with a coordinate R center and C center. Return the coordinate of all cells in the matrix sorted by the distance from R center to C center. Oh, okay. So, okay, let's say I have a by matrix, right? And I have it right here. Let's say this is the second case. C center, R row 0, column row 0, column 1, so it's going to be right here, right? What is the distance from here to here, from here to here, from here to here? Okay, output. They are all the same because the distance are the same. The distance is r1 minus r2, so r1 minus r2 plus c1 minus c2. So we don't have to like take the square root of anything. So let's say r1 minus r2, this is r1, right? r1 minus r2 is -1 plus c1, the absolute value. Okay, so that's pretty easy. Take the difference of this number minus this number minus that number, and we get the result. So that shouldn't be very difficult. Yeah. Okay. So what I'm going to do is I might just have a hash map here, actually. How would I want to do this? And sort the distance. Row column, that is the matrix. And we're trying to figure out every single cell in the matrix closest to itself. So R0, R center is 0 and 1. So that's always going to return the first one, right? 1 and 2, because the center, the distance is 0. So it's the closest one. I can start there, and I can go outward, that like an algorithm. Like I can start this center, right? And then look to see if there is one to the right of me, one to the left of me. And I can call a recursive function that return the entire thing at the end. How does that sound? How would I solve this in the most efficient way? I can iterate through the entire thing, like take this number minus this number. If it's a certain amount, then put it inside of the. I have to sort it later though. I still have to sort it later. I have to sort it later. Maybe I can use radix sort for this, because I know the distance. Yeah, I can use radix sort. So I'm gonna calculate all the value and put them inside a hash map, and then in the end I'm going to use like O n sort. That just gonna be super quick. Let's see. So yeah, I'm gonna take all the value, put it inside a hash map, and then I'm going to radix sort. So hash map. All right. And first thing I'm going to need is to calculate the distance and put that inside of hash map. So calculate the distance. So for I in range of int, in range of row, for R in range of row, for C in range of cols, right? So distance is equal to absolute value of R1 minus R2, so R1 minus R2, so that's R center minus ROR plus absolute value of R center C center minus C. Okay, if distance in hash map, then we're gonna append it to it. Hash map dot append at distance dot append distance dot append row and column. Okay. Else hash map at distance is equal to an array of R comma C comma C. So in the end, we're going to print out the hash map to see what we have inside. Okay, 0, 1. Expected 0, 0, 0, 1. Cool. So that's already sorted. If it's a 0, 0, 0, 0, 1, 2, 3. Okay, so that's fine. So now we're going to loop through. We're going to take the max of row and column, because giving us the max will have us, so we can iterate through the maximum. Let's say it's only like 20 row long. 20 row long, then it's going to be, I'm sorry, my brain is in motion at the moment. So max index is equal to max length. Max distance is equal to max of row or call. Okay, so now for I in range of max distance, ideally we can do like row minus row minus r center, whatever. We just do that, will be faster. For I in range of max distance, if I in hash map if I in hash map res equal to an empty array, res dot append hash map at I, and then return res. There we go. Okay. At 0. Output 1 0 expected 0 1. Okay. Okay, we're gonna print out hash map first here. Output 1 0 0 0. So that's the first one. We need the second part too. So we're gonna print out I here to see if it's looping through every single one of them, because I got a feeling it's not. Hash map, okay, 0 and 1. Okay. What about printing out for if I in hash map print out hash map? Run it. At 1 we have this. At 0 we have that. So at 0 we have 0 1. At 1 we have 1 2, and we have 2 here. Max distance plus 1, I think. Submit. Okay. Rows called. Output 0 1 0 0 1 0. Okay. Yeah, 2. 1 0 0 1 and then 1 0. It completely skipped 1. So why is 1 not in hash map? Print I. Print I in here to see if we're gonna get in there. Print I 0 1 2. Okay. So print hash map at I at 0. Oh, okay. Hash map at I 0 1 0 0 0, 0, 1, 1, and then 1, 0. Okay, that seemed to be working fine. Oh, I know why. So for each in hash map at I, at 0, I, res dot append each, res dot append each, and return we're going to return res, and that should work. Okay, okay, and I'm out of time. Okay, let's look at the solution. I need Python solution, Python 3, res dot sorts. Okay, they just appended all everything. Res dot append, and then it just sorted from x0 minus center plus absolute value of x center. Okay, and that just return res. Okay, that's pretty insane, man. Seriously, why do people keep saying like one liner? That is more like a nasty. Okay, easy solution. Python 3. I have the right approach. Yeah, this is ov(n) time. This is ovlog n time. It's not as fast as radix sort for sure. So I'm gonna try to do this with my solution because I'm pretty sure I'm very close. This is definitely ov(n). That one is okay. Row 3, comma 3, our center is 0. What am I missing this one? I'm missing the last one. 0, 1. I got most of this right. But on the last one, I'm messing it up. Okay, why don't we do row plus call? Row plus call. That is gonna loop through the entire thing. Every single one of them. Okay, there we go. That beats it. What I can do is I can do max distance. Distance equal to 0. So if I do if max distance is equal to max of distance or max distance, and now I can loop through max distance like a normal person and then return that. Come on, man. Okay, this is max distance not inclusive. Okay, that's not really fast. I don't understand how this is not fast. Okay, what is the fastest solution? It's not working. Distance equal to chord. Def distance chord is going to be. Okay, so this is returning a distance. Seriously, the sorted method is this is an O log n time. How is that faster than my hash map solution? I'm thinking it's my hash map. That's definitely my hash map. How can I speed this up a little more? Distance is equal to absolute value of that minus that. Okay. Max distance is equal to, we're comparing this every time here. If distance in hash map, distance dot append, this is a lot of conditional. This is an ov(n) operation. We're looping through every single one, getting every single one of them. And this is another ov(n), so that should be ov(n), right? O2n. The other one is O(n) of log n, which is not, maybe the data set is just not big enough. I don't understand how this is faster. Yeah, but this is ov(n) operation. The other one is just using, this is the, well, okay, let me just ask ChatGPT what is the time complexity of these. Okay. Chat, what is the time complexity of this solution? Solution. That's got to be ov(n) log n. the creation of the cell by sorting a list. List creation, that is O of n square, right? O of n row column. Sorting using time sort. The sorting of a list is based on Manhattan distance of each cell from a given cell. The time complexity of sorting algorithm is using time sort is O of n log n, where n, yeah, this is O of n log n. Okay, what is time complexity of my code? This is O of n. How about this one? How about this one? Create a hash map dictionary. Maybe the hash map looking up is really slow. Hash map lookup can be slow. Maybe that's why. Finding the max distance. It's an updated, it's in the same loop. Oh, you know why? Okay, how about this? So instead of a hash map, I can use an array. Yeah, I can use an array. So res is equal to an array. Res is equal to an array, a giant array. So I know for sure now res array, or R is equal to an array, and we're going to put an empty array of each inside of that. An empty array time rows plus call, row plus call. Okay, now we're going to print out, I want to see what this is. Print out R. I want to see what that is. Okay. For in range, range of row, hash map is slow, that's why. Okay, so there is max distance is 3, there's 3 in there. It's 4, there's 4 in there. Max distance 5, there's 5 there. Okay, so that should work. So instead of doing this hash map doodad, we can say r at distance dot append r comma c. In n, we're going to return print r. Now that should be sorted. 0, 0, 0, 1, cool. How about this case? 0, 1, 0, 0, 1, 0, 1, 0. Okay, so that's sorted. Now how about this one? 1, 0, 0, 0, 0, 2, 1, 1, 0, 1, 1, 0, 0, 0. Cool, so that's sorted. So now what I'm going to do is I'm going to I don't need max distance anymore. I don't need to do the distance comparison. So what I'm going to do now is I'm going to move everything. I'm going to shift it over. So if this number in the middle is empty, I'm going to shift it over 1. No. Okay, how about we just return a new array? No, that would be too easy. Yeah, you know what? I'm going to add, if it's not empty, then I'm going to append, and you might as well just append into a new array. Yeah, I'm going to append res is equal to a new array, right? For I, for each in range, for each in R, if R not equal to an empty array, res dot append each, and in the end we're going to return res. What? Res dot append each. Okay, what is going on with this? Why don't we just return empty array for now? Let's just print out each, or print out res. Alright. I'm not smoking. 0, 1, 0, 0. Res is an empty array of each. for 0, 1, 0, 0, and there's an empty array, not equal to an empty array. If r dot length, if length of r if length of r is more than 1, more than 0, okay, length of each, oh, I'm sorry, that's sorry. If each not equal to an empty array, prints res. Zero, 1, 0, 0. Okay, there we go. Now we can just return res. Okay. Print res. If we're gonna get an error message, I might as well figure out why. std out. Oh, there's an array inside of array. Okay. Res to append each. Oh, wait a minute. Because there can be more than one. Res for each, for item and each. Res dot append item. Now we return res, and that should be fast enough. Okay. Submit. 120 millisecond. All right, that's faster. Now how can I make this faster? I'm gonna run it again. 130. Come on. Give me a break. That's gotta be faster than the ov(n) log(n) short. I don't know why this is faster. That is ov(n) log(n). What if we we have to calculate the distance no matter what. Maybe there's a faster way of doing this. What if we work backward? What if we do distance? Because we have to calculate the distance anyway, right? What if we do the way backward? What if we do distance? Well, if you think about it, if we have the same column, right? Distance plus equal to, what if we can omit the second loop right here? We can omit the second loop right here. Because if we take r center minus r, we know that the further away we are from the center, there's an easier way, there's a faster way of doing it. I just don't remember how. There's a way to do it in ov(n) time, not even ov(n) square time, ov(n) 2 time, ov(2n) time. Okay. How would you optimize? Let me just ask ChatGPT. There's a faster way. How would you optimize this solution to run in ov(n) time only? Yeah, because for one, this is ov cube, do ov(n) times 3, because we're allocating space for the array, right? And then we are removing. Yeah. That's a way to do this, but I just don't remember. I just don't know how to This is really slow, Python. because we are pending. Okay, Python, how to allocate space for an array of size. Yeah. Hang on, this is kind of slow. Okay, how do I make this faster? How do I allocate space? In Python, in Python, how do I allocate an array of size? Faster way of doing it. Is there a faster way of doing it? Okay, so let's just do this on Java. Let's see what happened. I haven't coded in Java for a very long time, so we'll see how this is gonna go. So, vector Java, how to create an array. Array in Java. Int array. Okay. Int r of size row plus call. Int size of row plus call. New type var name new type var. Okay, so r is equal to int new int array. Okay, new int array of size rows plus calls. Okay. Okay, so let's just run that to see if nothing breaks. Okay, calls semicolon. Okay, for int I equal to 0, for r equals 0, r less than calls or rows, r plus equal plus plus, r plus for int c equals 0, c less than calls, c plus plus. Now we're going to distance. Int distance is equal to abs map dot absolute value of r center minus r plus math dot absolute value of c center minus c. Okay, so r at distance is equal to an array of r and c. In the end, we're going to do system dot out dot println r. Oh my god, this is why I do not like Java. It's so verbose, so tedious. Okay. Missing a semicolon, and how do I assign? Dot push, right? R, C. push an array. Okay. What's wrong with this code? Incorrect array initialization. New int decreates array size row plus call. Ah, okay. So maybe I have to do okay. Run it. Illegal start of an expression. How do you mean? In row. Oh, I know why. I know why. Because it's an array list. New array list. New. Array list. Array list. Array list. Row plus call. Okay, you know what? I give up. I give up. I really give up. I'm gonna go back to my good old Python solution and then call it a day. Goodbye.